Hello, Dr. Co. My name is Jace Headings. Today I'm going to derive the basic equation of statics and apply this equation to calculate the air pressure at varying altitudes assuming constant temperature. Let's start with a cube which has a height we'll call dz and a few areas, one on the top and one on the bottom. These areas have pressures associated with them. We'll call them P1 and P2. And they also have forces associated with them. Let's call them F1 and F2. It also has a force of gravity. Now, making a force balance, we get negative F1 plus F2 minus the force of gravity equals 0. These are negative because this is the positive z direction. Substituting force equals pressure times area and force of gravity equals density times volume times gravity, we get negative pressure 1 times area plus pressure 2 times area minus density times area times height. This is for the volume times gravity. While we're at it, we'll move this to the other side, cancel out our areas, and divide by the height. Now we have pressure 2 minus pressure 1 over the height equals density times gravity. From here, we'll assume that the pressure at the bottom is 0. And this will now be the change in pressure from the bottom to the top. So we have negative dp over dz, change in pressure over change in the height, equals the density times gravity. Changing the sign, we'll get the change in pressure over the change in height equals negative density times gravity. This is the basic equation of statics. Now, to apply this to air pressure at varying temperatures, we want to move the height to the other side and substitute density equals Pm over RT into the equation. This will get us the change in pressure equals negative Pm over RT G dz. Moving pressure to the other side, we get 1 over P. From here, we want to integrate. We'll go from P1 to P2 to show the change in pressure, and Z1 to Z2 to show the change in height. This integrates to natural log of P1 over P2, and this equals negative molar mass times gravity over the R constant times T, which is also a constant in this case, times Z2 minus Z1 for the change in height. Getting rid of this natural log and moving the P2 to the other side, we have P2 equals P1 times exponent negative mg over RT, all a constant, minus, or times the change in height, Z2 minus Z1. Now, given this equation, we can substitute a change in altitude and the pressure relating to the first altitude to get a final pressure. Thank you.